In 22 years, one immigrant entrepreneur turned $100 million and 3 exploded rockets into a $350 billion aerospace empire. He had no rocket engineering degree. He had no government contracts. He had a stack of Russian textbooks and a stubborn refusal to accept that launching things into space had to cost what NASA said it cost. On August 2, 2008, on a remote atoll in the Pacific called Kwajalein, the third Falcon 1 rocket lifted off, made it 217 seconds into flight, and disintegrated. SpaceX had roughly enough money for one more attempt. 1. The company was, charitably, in a difficult spot. What happened in the next 6 weeks rewrote the economics of an industry that had been frozen since 1969, and it set up the single most valuable private company on Earth. Here is exactly how it happened, and the moment SpaceX became unstoppable. I am Tycoon Decoded. Today, how Elon Musk built a $350 billion rocket empire in 22 years, and why Boeing and Lockheed, with 60 years of NASA contracts and tens of thousands of engineers, completely missed the technology shift happening right under their noses. To understand SpaceX, you have to understand the industry it walked into. In 2001, getting 1 kilogram of payload to low Earth orbit cost around $10,000. That number had not meaningfully moved in 3 decades. The launch market was controlled by a handful of defense contractors and national space agencies. Russia, the United States, France. Rockets were expendable. You built a $60 million machine, flew it once, and dropped it in the ocean. Imagine throwing away a Boeing 747 after every flight to London. That was the business model. Elon Musk, having just sold PayPal to eBay for $1.5 billion, became obsessed with putting a small greenhouse on Mars, a publicity stunt to reignite public interest in space exploration. He flew to Moscow 3 times in 2001 and 2002, trying to buy refurbished intercontinental ballistic missiles to use as launch vehicles. The Russians, in a moment that probably haunts them, laughed at him and quoted a price he considered insulting. On the flight home, Musk opened a spreadsheet. He calculated the raw material cost of a rocket: aluminum, titanium, copper, carbon fiber. The math said the materials were roughly 2% of the price the industry charged. The other 98% was inefficiency, monopoly pricing, and what economists politely call cost-plus contracting. Musk founded Space Exploration Technologies in March 2002 with one contrarian bet. If you build rockets like a tech company, instead of like a government contractor, you can drop the cost by an order of magnitude. Vertical integration, in-house manufacturing, software-driven iteration. Wall Street, never one to miss an opportunity to be wrong about technology, ignored him entirely. But the bet that turned this into a $350 billion company was not the one anyone expected. Here is what actually happened. The first product was the Falcon 1, a small 2-stage rocket designed to carry roughly 670 kilograms to low Earth orbit at a target price of $6 million per launch. For context, the cheapest competitor was charging 4 times that. SpaceX set up shop in a warehouse in El Segundo, California, hired a small team of obsessive engineers, and started building. Tom Mueller, a propulsion engineer who had been building rocket engines in his garage on weekends, designed the Merlin engine from scratch. The team chose Kwajalein Atoll, a U.S. military site in the Marshall Islands, as their launch site because the FAA permitting was simpler than mainland options. The reality was that Kwajalein was 4,800 miles from Los Angeles, and the only way to move hardware was a chartered cargo flight. Every screw, every wire, every cup of coffee had to be flown in. On March 24, 2006, Falcon 1 attempted its first flight. A fuel leak caused a fire. The rocket fell back onto the launch pad after 33 seconds. On March 21, 2007, Falcon 1 Flight 2 made it to 289 kilometers altitude before a control issue caused it to tumble. On August 2, 2008, Flight 3 carried 3 satellites and human ashes as a memorial payload. A residual thrust issue caused the first stage to bump the second stage during separation. The rocket failed. SpaceX had now spent roughly $100 million of Musk's personal PayPal money. Tesla was simultaneously running out of cash. Musk was, according to his own accounts, sleeping on factory floors and borrowing money for rent. The company had funds for exactly one more launch attempt. If Falcon 1 Flight 4 failed, SpaceX would close. On September 28, 2008, less than 2 months after the third failure, Falcon 1 lifted off from Kwajalein for the 4th time. It reached orbit. SpaceX became the first privately funded liquid fuel rocket company in history to put a payload into orbit. 3 months later, on December 23, 2008, NASA awarded SpaceX a $1.6 billion contract for 12 cargo resupply missions to the International Space Station. Musk later said he received that phone call and could barely speak. The company had been 6 weeks from bankruptcy. So what did NASA see in a company that had failed 3 times in a row? They saw the only American option that was not Boeing or Lockheed Martin charging $400 million per launch. The Falcon 1 success unlocked something bigger than a single contract. It validated the entire commercial spaceflight thesis. SpaceX immediately pivoted upward. The Falcon 1 was retired after only 5 flights. The team began full-scale development of the Falcon 9, a much larger rocket capable of carrying 13,000 kilograms to low Earth orbit. 9 Merlin engines clustered on the first stage. Same engine, more of them. This was vertical integration as religion. By 2010, SpaceX was manufacturing roughly 80% of its rocket components in-house. Compare that to traditional aerospace, where a single rocket might involve 1,500 subcontractors across 40 states, each one optimizing for their own margin and politically protected by their local senator. Musk called the legacy approach a logistics nightmare disguised as a supply chain. He was not wrong. On June 4, 2010, Falcon 9 made its first flight and reached orbit on the first attempt. On December 8, 2010, SpaceX became the first private company to launch, orbit, and recover a spacecraft when the Dragon capsule completed 2 orbits and splashed down in the Pacific. Only 4 governments had ever done this before. Then came the audacious bet that everyone in the industry said was impossible: reusability. The conventional wisdom was that you could not land a rocket booster vertically after a launch. The aerodynamic forces, the fuel cost of slowing down, the precision required. Every credible aerospace engineer for 60 years had concluded reusability was either impossible or uneconomical. SpaceX began testing landings in 2013 with a vehicle called Grasshopper. The first attempts to land a Falcon 9 booster after orbital launch happened in 2014 and 2015. They failed, repeatedly. Boosters tipped over, exploded on barges. One famously hit a drone ship at an angle and crumpled like a soda can. The internet had a wonderful time with the bloopers reel. On December 21, 2015, Falcon 9 returned to Cape Canaveral and landed upright on a concrete pad. The first orbital-class booster ever recovered intact. On April 8, 2016, SpaceX landed a booster on a drone ship in the Atlantic Ocean for the first time. The same booster flew again in 2017. The economics of spaceflight changed permanently. A new Falcon 9 first stage costs around $30 million to manufacture. Refurbishing a flown one costs a fraction of that. By 2024, SpaceX had flown some boosters more than 20 times each. The company was now charging customers roughly $67 million per Falcon 9 launch, undercutting every competitor by 40 to 70%, while still earning healthier margins than anyone in the industry. By 2018, SpaceX was launching more rockets per year than any other country except China. By 2020, it had eclipsed China. In May 2020, the Crew Dragon carried NASA astronauts Bob Behnken and Doug Hurley to the International Space Station. The first crewed orbital flight launched from American soil since the space shuttle was retired in 2011. A private company had taken 9 years to replicate what a $196 billion government program had abandoned. But the real money was about to come from somewhere else entirely. Why does the most valuable rocket company on Earth derive most of its revenue from the internet? Because in 2019, SpaceX started launching Starlink. The plan was to deploy thousands of small satellites in low Earth orbit to provide global broadband internet. The strategic logic was elegant. SpaceX had the lowest launch cost in the world by a wide margin. Every other satellite internet company had to pay market rates for launches. SpaceX could simply use its own rockets, at marginal cost, to deploy a constellation no competitor could match. By 2024, Starlink had over 6,000 satellites in orbit and roughly 4 million subscribers across 100 countries. Annualized revenue crossed $6.6 billion. The unit economics were finally working. In a single decision, Musk had turned a launch company into a vertically integrated telecommunications empire. SpaceX was no longer just a rocket builder. It was a recurring revenue technology company that happened to own a launch business. The valuation reflected this. In December 2024, a tender offer valued SpaceX at $350 billion. That made it the most valuable private company in the world, ahead of ByteDance, ahead of OpenAI. For a company that, 16 years earlier, had been 6 weeks from bankruptcy on a Pacific atoll. Meanwhile, Starship development was accelerating in Boca Chica, Texas. Starship is the fully reusable super heavy lift vehicle that, if it works, will carry 150 tons to low Earth orbit at a marginal cost that may approach $10 million per flight. On October 13, 2024, on its 5th integrated test flight, the Super Heavy booster returned to the launch tower and was caught mid-air by 2 enormous mechanical arms that engineers had nicknamed the chopsticks. Watch the footage. A 70-meter-tall booster descending from space, slowing to a hover, and being plucked from the sky by a tower. It looked like science fiction filmed in a Texas backyard, because that is essentially what it was. Here is what most people miss about SpaceX. The conventional narrative says SpaceX won because Musk is a genius and pushed harder than anyone else. That is partially true and almost entirely beside the point. The deeper story is that SpaceX won by treating rockets as a software problem. Why does that distinction matter when you are building hardware that explodes? Because the aerospace industry, for 60 years, treated rockets as artisanal craft. Every component was custom, every mission unique, every failure a justification for more layers of review. SpaceX inverted the model. Build cheap, fly often, fail fast, iterate. The Falcon 9 has flown over 400 times. Each flight generates telemetry data that improves the next one. Starship has exploded in spectacular fashion multiple times, and each explosion was treated not as a setback, but as a paid data collection event. The competition still treats a rocket failure as a career-ending catastrophe. SpaceX treats it as Tuesday. The second hidden advantage is the talent flywheel. Working at SpaceX is brutal. 80-hour weeks, intense scrutiny, public failures. But for a certain type of engineer, it is the only place on Earth where you can put hardware in orbit before you turn 30. SpaceX has become the prestige employer of an entire generation of aerospace talent. Boeing and Lockheed, in a development that surprised exactly nobody who had ever interviewed there, struggled to compete for the same engineers. The third thing people miss is the vertical stack. SpaceX builds the rocket, owns the launch site, operates the satellites, sells the internet service, and increasingly builds the ground stations. Each layer subsidizes the next. There are 3 lessons here for any entrepreneur. First, attack industries that have not been forced to compete. Aerospace had no real price competition for 40 years. The complacency was the opportunity. Look for markets where the incumbents have never had to ship faster or cheaper. Second, Vertical integration is a weapon when the supply chain is broken. SpaceX would not exist if Musk had tried to coordinate 1,500 subcontractors. Bring it in-house, especially when the existing supply chain is the source of the dysfunction. Third, treat failure as paid research. Every Falcon 1 explosion taught the team something a simulation could not. If your iteration cycle is faster than your competition, you will win, even if your individual attempts look worse on paper. Speed of learning compounds. Next time on Tycoon Decoded, how Jensen Huang built NVIDIA into a $3 trillion AI infrastructure empire in 31 years. Subscribe so you do not miss it. We publish a new modern empire case study every week, breaking down the strategy, the timing, and the contrarian bets that built the most valuable companies of our generation. See you on the next one.